Here we are back to section 4.1. So this is where we get introduced to what's called U substitution. I like to say U stands for ugly. So you pick the thing that looks ugly, you call it U, and then you substitute out so you're looking at something in terms of U instead of looking in terms of whatever the ugly was. Now in calculus, you have the U substitution, and then you have to figure out the derivative of it to do some crazy stuff with integrals. But picking what ugly is and learning how to practice with it is an excellent skill that you can use all over the place. So here we have a trigonometric expression, which is 2 cosine squared theta plus cosine of theta minus 1. So notice it has that quadratic pattern, a squared thing, a linear thing, and a constant term. So we're going to turn this into a quadratic. So my u here, my ugly, is the cosine of theta. So my u squared is cosine squared theta. So I'm going to trade out those substitutions here. So this is now 2u squared plus u minus 1. And now I can factor this. And we are going to see at the end of this chapter where we're going to have this, but it's an equation. And you got to be able to factor or use the quadratic formula to figure out the factors, because that's where we're actually going to solve the equations. So you want to practice with this now, get comfortable. All right, so number of ways to factor. Here, a times c is negative 2u squared. So I can get negative 2 by multiplying a positive 2 and a negative 1. So that is what I'm going to split my middle term into. So let me just write what I was thinking. All right, so negative 2u squared I can get by multiplying positive 2u times negative 1u. And if I add those, I'll get positive 1u, which is what I want. So I'm going to say my 1u here is the same as 2u minus 1u. Then I'm just going to recopy the other parts. And now we look at factor by grouping. So my front two here both have a 2 and a u. So let me real quick do that. So we're going to factor out the 2u they have in common. And then I'm going to figure out what I would have to multiply by so it could be equivalent. So 2u times another u would get me 2u squared. Plus, I have the entire 2u here. So I need a 1 as a placeholder so it would multiply back and be equal. Now over here, I'm hoping that I'll also see a u plus 1. And if I look, both of these are negative. So I'm going to factor out a negative 1. Negative 1 times u would get me back to negative 1u. And negative 1 times a positive 1 would get me back to negative 1. So notice those u plus 1s are now the same. So I have a whole bunch of things being multiplied minus some things being multiplied. Those two multiplication mishmashes both have u plus 1 as a common factor. So I'm going to write that up front. And then I'm going to write my leftovers, which is the 2u minus 1. So that is now our weird quadratic factored. Now, all we have to do to finish this out is, instead of my u's, I'm going to write cosine again. So this is the cosine of theta plus 1 and 2 cosine theta minus 1. So if this was actually a quadratic equation, It would have been equal to 0 before we bothered to factor, because we need it to be a 0. Then I can set the factors equal to 0, because for a product to be 0, at least one of the two things must be 0. And then I'd have some mini trig equations that I can actually solve and talk about what the solutions would be. But for right now, we're just practicing the ugly substitution factoring part. And then here we have doing it again. So now 25 and the 9, they're numbers. We're used to dealing with numbers. The sine squared, though, looks a little weird, so we'll go ahead and use our u. All right, so if u is sine theta, u squared is sine squared theta. So my expression here, 25 minus 9, I'm going to write u squared now. Now, whenever you have two terms like this is a difference of squares. So let me kind of write the just generic formula for that. A squared minus b squared will always factor into a plus b times a minus b. Now you could also write a minus b times a plus b. The order there doesn't matter, but if you see two terms, there's a minus in between them, and the things are squared, difference of squares factoring. The one that we just saw previously was when we had the 1 minus sine times 1 plus sine. That multiplied into 1 minus sine squared. So that was multiplying up to a difference of squares. This is undoing that process. So 25 and 9 are both perfect squares. So for my 25, I'm going to put a 5 and a 5. For my 9, I would put a 3 and a 3. And my u squared will split into u and u. Make one positive and the other negative. There's our factoring. And now I'm just going to come back and fill in. So it's 5 plus 3 sine theta times 5 minus 3 sine theta. Now you might be comfortable enough to jump from the original problem to this line down here, and that's fine. You don't have to use the u substitution here, but it's something that you should be familiar with as an idea for something you can do. But that's all we could do right here, and that's all they're really wanting you to practice is if we have just a little quadratic like this, can you factor it? All right, and then this last one is like one of the most quintessential classic obnoxious trig proofs. We have a fraction equals a fraction. The easiest thing to do would be to say, okay, we cross multiply and go from there. And it is so tempting, but we can't do it. So now one side is about as ugly as the other side. So I'm just going to take the left and move to the right. Just that's my habit. All right, so we are starting with cosine of theta divided by 1 plus sine of theta. Now, if we cross multiplied, I'd be multiplying this 1 plus sine theta times 1 minus sine theta. And hopefully, since we've been doing that factoring, that should like ring a bell about, oh, that'll multiply nicely. So I can't cross multiply, but I can take that choice thing I wanted, and I'm going to multiply on the top and bottom by it. Or you can also think of it as, well, I want to see 1 minus sine theta on top, so I'll multiply by that on the top and bottom. I'll just sneak some parentheses back around there. All right, so since I want to see 1 minus sine theta on top, I'm not going to multiply those. I'm going to keep them separate and hope that the cosine will eventually cancel with something. So now our top is the cosine of theta times 1 minus the sine of theta. And then on the bottom, that is a difference of squares. So we're going to have 1 minus sine squared theta. The outside and inside terms will cancel, and we get this. But 1 minus sine squared, there's our Pythagorean identity kicking in. If sine squared plus cosine squared is 1, 1 minus sine squared is the guy we don't see, cosine squared. And now I have a cosine on top and cosine times cosine on the bottom. So this is going to cancel one of the cosines out. And we are left with 1 minus sine theta over just a single cosine of theta, which is exactly where they wanted us to go. Duh. Now, some of the uglier ones, you might have to play around with it, try a few different things. If you get flustered, like put it down, walk away from a bit, like play a game on your phone, set a timer for like 15 minutes, play for a bit, then come back and see. If that doesn't help, sleep on it. Your brain thinks while you're sleeping, it's using your dreams to kind of process. And sometimes when you wake up and you go and look at your work, like it's, aha, I have a thing to try now. If not, talk it over with one of your classmates. Sometimes just talking the problem out loud can help. Just help you see something you didn't see before, or notice something, or spark something. Alrighty. So that is all I have for notes for 4.1. It's mostly just play around until it works.